All right, let's jump right in. Welcome to this explainer, where we're decoding the massive, high-stakes world of the industrial machinery sector. We're looking at this through the lens of the SICS RTIG standard. When we talk about industrial machinery and goods, we're talking about the absolute heavyweights of our global economy, right? The literal backbone of construction, agriculture, energy, transportation, you name it. But how do we actually measure the sustainability, the hidden risks, and honestly, the immense financial opportunities inside such a colossal, resource-heavy industry? Well, that's exactly what SICS RTIG is designed to do. It serves as a comprehensive blueprint right under the resource transformation sector.
And we're anchoring this right in reality. Under the stewardship of the International Sustainability Standards Board, or ISSB for short, companies are held to a really rigorous framework. Basically, IFRS S1 mandates that entities use these very SASB standards to pinpoint their sustainability-related risks and opportunities. So we aren't just talking about, abstract environmental goals here. We're talking about identifying specific, hard metrics that could reasonably be expected to affect a company's cash flows, their access to finance, and their overall cost of capital.
So, here is our blueprint for today. We're going to map out 5 key stages: the Global Sustainability Blueprint, defining industrial machinery, powering the factory floor, product use and emissions, and finally, supply chains and remanufacturing.
Okay, Section 1, the Global Sustainability Blueprint. Moving right along to Section 2, defining industrial machinery. What's really fascinating here is defining exactly what this RTIG industry actually builds. The visceral scale of these operations is just wild. This isn't light manufacturing by any stretch. This is heavy industry at its absolute most foundational level. This sector manufactures the titans of industry. We're talking about massive engines that power marine vessels, huge earth-moving equipment carving out infrastructure, commercial trucks, agricultural tractors, locomotives, industrial pumps, and giant turbines. The demand for all this stuff is deeply tied to global industrial production. But at the exact same time, shifting customer demands and super strict government emission standards are forcing these manufacturers to innovate faster than they ever have before.
And the physical production process? It's a massive undertaking. Step 1 requires staggering volumes of raw inputs. Imagine tons and tons of steel, iron, plastics, rubber, paints, and glass. In Step 2, these raw materials don't just magically snap together. They require intensive machining and casting. Finally, Step 3 brings the whole shebang together in final assembly. Just imagine the sheer energy and labor required to transform raw steel plates into a functional locomotive or a high-efficiency turbine. It's incredible.
So to measure the financial risks and opportunities across this really intensive life cycle, the SASB standards lay out a comprehensive map of core disclosure topics. These basically break down into energy management, workforce health and safety, fuel economy and emissions, material sourcing, and remanufacturing design and services. Every single one of these metrics directly ties back to an operational reality that hits the bottom line. Which brings us to Section 3, powering the factory floor.
Moving on to that factory floor, we hit our first 2 massive operational realities: energy consumption and workforce safety. I mean, you absolutely cannot build heavy machinery without consuming vast amounts of power. Let's look at the energy mix. Because purchased grid electricity is typically the largest energy expense here, followed pretty closely by purchased fuels, companies have to disclose their total energy consumed in gigajoules. But just giving an aggregate number isn't going to cut it. They have to break down the exact percentages of grid electricity versus renewable energy. This is vital for investors to assess cost structures, energy reliability, and regulatory risks around fossil fuels.
Now, a crucial point here, you can't just slap a green label on your factory and call it a day. The standard is incredibly strict. Renewable energy is strictly defined as sources replenished at a rate greater than or equal to depletion. Think geothermal, wind, solar, hydro, and certified biomass. To actually claim renewable energy usage, companies have to rigorously track the data and retain specific certified guarantees of origin or renewable energy certificates, often called RECs. Actually, here's a crazy detail. If a company generates solar power on-site but then sells those RECs to someone else, they cannot claim that power as renewable for themselves under this standard. No double dipping allowed.
On the safety side, we have this very specific critical number, 200,000. Workers on these factory floors face serious hazards every single day, from heavy machinery, moving equipment, high-voltage systems, so creating an effective safety culture is completely non-negotiable. To standardize how we measure this across the whole industry, incident rates are calculated against a baseline of 200,000 hours. Why 200,000? Well, it perfectly represents 100 full-time workers, putting in 40 hours a week for 50 weeks a year. It perfectly levels the playing field, so you can compare a massive corporation to a smaller manufacturer.
Against that 200,000-hour baseline, entities have to report 3 distinct safety metrics: the total recordable incident rate, the fatality rate, and the near-miss frequency rate. A near-miss is particularly important to track. It's an unplanned event that didn't result in injury or damage this time, but easily could have under slightly different circumstances. By proactively tracking these rates for both direct employees and contract workers, companies can mitigate massive healthcare costs, litigation, and crippling work disruptions.
Section 4. Product Use and Emissions.
Once the machinery finally leaves the factory floor, it enters the use phase. This is where intense customer demand for efficiency, combined with strict government emission standards, really drives the need for innovation. But we have to adapt our measurements depending on the machine's actual job. For instance, for medium and heavy-duty commercial vehicles moving freight, the standard measures efficiency in liters per 100 ton-kilometers. But what if we're evaluating an excavator or a farm tractor? They don't primarily travel distances, they sit there and perform stationary, heavy work. So for non-road equipment, it's measured in liters of fuel consumed per hour of operation. Makes sense, right?
Beyond just fuel efficiency, we have direct air emissions. Manufacturers have to calculate the sales-weighted average emissions of nitrogen oxides, or NOx, and particulate matter, PM. This is measured in grams per kilojoule, and it has to be broken down across specific categories: marine diesel, locomotive diesel, on-road heavy-duty, and other non-road diesel engines. That sales-weighted part, that is key. It means a company can't just boast about one ultra-clean prototype if they're simultaneously selling thousands of highly polluting legacy engines. The data reflects reality.
And the standard pushes way beyond just simple numbers. This is not just a data entry exercise. The SICS framework requires a deep, qualitative discussion. Companies must provide a robust breakdown of exactly how they're managing fleet fuel economy and emissions risks. They have to lay out their strategies. Are they relying on tweaking existing products? Pouring money into R&D for advanced technologies, maybe partnering up with academic institutions? The companies that successfully innovate here are the ones who are going to capture expanding market share while actively slashing the regulatory risk.
All right, Section 5, Supply Chains and Remanufacturing. Finally, we reach the actual physical materials that make up these machines and the incredible opportunities available when those machines reach the end of their operational life. This leads us to the multi-million-dollar question keeping supply chain managers awake at night. With such a heavy reliance on essential materials sourced from only a few specific countries, how do companies navigate geopolitical uncertainty and extreme pricing volatility?
Well, the standard defines a critical material as one that is essential in use but highly subject to supply restrictions. We're talking about crucial elements like cobalt, graphite, platinum group metals, and rare earth elements. Because global demand for these from other sectors is just skyrocketing right now, entities must explicitly identify which of these materials pose significant risks to their operations. But identifying the risk is only half the battle. They also have to detail their mitigation strategies. Are they diversifying suppliers, strategically stockpiling, aggressively developing alternative materials, or maybe investing in specialized recycling technologies?
And that focus on recycling and material recovery leads us directly into a massive, and I mean massive, financial opportunity: remanufacturing. Notice this definition carefully, because this is not simply repairing a broken part. A remanufactured product is an end-of-life component, often called a core in the industry, that has undergone a rigorous industrial process to be returned to its original, like-new working condition.
By reusing these end-of-life cores, heavy machinery companies can drastically reduce their demand for new raw materials, like all that steel and plastic we mentioned earlier, while simultaneously slashing their manufacturing costs and production time. Because this is such a potent value creator, companies must explicitly report their revenue from these remanufactured products and services. They also need to detail the exact initiatives they use to secure these cores in the first place. Stuff like product take-back programs, exchange systems, or dealer deposits that actually incentivize customers to return their used parts.
So, as we wrap up this explainer, we really have to ask ourselves, how will these exact innovations in remanufacturing, critical material substitution, and energy efficiency completely reshape the future of heavy industry? The companies that master these metrics aren't just going to be compliant, they are going to be the dominant, unstoppable forces in the market of tomorrow.
The SICS RIG-IG standard clearly illustrates that measuring sustainability is no longer just some peripheral reporting task. It is the ultimate blueprint for mitigating existential supply chain risks and capturing profound global financial opportunities. If you really want to understand the true health, resilience, and future profitability of an industrial machinery company, you look right here, at these exact metrics. Thank you so much for joining me on this deep dive. Leave a comment below with your thoughts. Is remanufacturing the key to the future, or will a breakthrough in alternative fuels change everything first? Keep learning, and I'll see you in the next explainer.